Good morning to all. I am Kiran Pachlasiya, Assistant Professor at Sagar Institute of Research and Technology, Bhopal, the SAGE Group. Today I am going to discuss about grammar in theory of computation, how we can define grammar and how grammar is recognized with the machine. Later on, we also discuss on context-free grammar, what is context-free grammar and how it is generated. First of all, when we talk about the language is recognized with some type of string. When we talk about language, there are two terms known as acceptor and generator. The language which is accepted by some machine, that is called acceptor. Some machines like FA, PDA, Turing machine, these are the acceptor for the language. On the other hand, when we talk about generator, so language is generated by grammar. In normal language, where we find grammar, suppose we have a sentence. On that particular sentence, there are some noun, there are some article, there are some verb. So when we create a sentence, we use noun, article, verb, helping verb, and something like that. Similarly, in TOC also, when we create grammar, we need some verb, noun, article. In TOC, this verb, noun, and article are named differently. Suppose and in English, article are a and the, noun are, let's having this example, boy and dog. Verbs are runs and sleep. So what are the sentence we are creating with this language? We are creating the boy is sleeping, the dog is, sorry, the boy is sleeping, the boy is runs, the dog runs. This type of sentence we are created from this grammar. And now we are talking about TOC. So grammar consists of 4 tuples. The 4 tuples are VTPS, where V stands for all the vertices which is producing any term. This LHS of left hand side of any production, if there is variable and terminal or combination of variable and terminal, are called as vertices. That means on the LHS, whatever it is, this is called V. Terminals in whole grammar, your whole rules, this is called rules. There is terminals. Terminals means any number 0, 1 or small alphabet or any symbol like asterisk, parenthesis and all. These are known as terminals. So in this grammar, here we have two terminals called A and small b. And also we have next production, S produces epsilon. So now P stands for the whole, this combination. S produces A, S, B, and S produces epsilon. This is known as production. And when we talk about S is the smallest symbol of the production. So here S is the starting symbol. So now we are moving on. What we have created for this given production, which type of language we are producing with this given production. So first of all, we will take S produces A as B. Here we have to taken S produces A as B. Now in the place of this S, we can substitute another A as B. This A as B implies that this A is replaced by this A as B. Similarly, here we replaced the S with A as B. And finally, we will replace this S with epsilon. So what we are getting? We are getting the string of 3A and 3B. And in other derivation, we are substituting same here, and at last we are getting 4A, string of 4A and 4B. So what we will analyze in this example is this whole production is this whole production has produced number of A equals to number of B, A followed by B. So what is this language means? This language accepts all the number of A, number of B, which is greater than equal to 0. Why greater than equals to 0? Because first production when we substitute, we are having, when we put epsilon here, we are getting first A and B. And when we are only substituting epsilon, so we are getting what? Epsilon in this given grammar. So hence we will see in next topic, context-free grammar. Finite automata accept all regular language and only regular languages are accepted by finite automata. Many simple languages are non-regular. Why? Because of the conditions they have. Context-free languages are a large class of language that encompasses all regular language and many other including the two above. Languages that are generated by context-free grammar are context-free language and that are accepted by push-down automata. Context-free grammar are more expressive than finite automata. If a language L is accepted by a finite automata, then L can be generated by a context-free grammar. Context-free grammar also have four tuples, which is VTPS, similar as every grammar have. A language L is context-free if there is context-free grammar. We already seen this example, A to the power n, B to the power n, where n is greater than equal to 0. Just suppose that if given that all the string of balance parentheses. So now in previous section, we are discussing about how we can create a string here. How we are creating a string with the given production rules. This is the rules. And here what we are doing, we are producing grammar by given conditions. So what is the condition is create parenthesis all the string of balance parenthesis. So the idea is how you can create balance parenthesis. Means you have to work on left hand side and right hand side equally, similar to that A and B example. Suppose if we are having left parenthesis and in between we introduce a new symbol or variable called P, then we are putting right parenthesis on it. So how can it works? It works like that. If I am introducing a variable, putting left and right parenthesis, in between I am putting this variable as it is. So it will gives me the one parenthesis. Now also we need balanced parenthesis. Suppose if I put oblique 1p, so what I get here, what odd number of parentheses. But suppose a string is this type, two left parentheses followed by two right parentheses. So what the production develop is p produces epsilon. Why? Because if I put here an epsilon, so what I have get balance parenthesis. So we are taking p produces left and right parentheses, in between we are taking p. Then this p is replaced by this combination left and right parentheses with p, and at last we put epsilon in the place of p. So hence we get the combination of the given string. So thus easily we can convert any string into its grammar. This is some homework for you all. Do it nicely. I am giving one hint in this. When a to the power n, and b to the power n and c to the power m plus n, first we will separate these rules into this kind of part. A to the power n, m, b to the power n, c to the power n, c to the power m, and then m is plus because base are same. And how can you create a string of a and b with double number of c? Thank you. Stay tuned. In next topic, we will discuss about the derivation. How can we get the string from the grammar? This is called derivation. Later on video, we will discuss about that. Thank you so much. Keep learning. Stay tuned.